All right, so we've done 5 videos, probably like 2.5 hours or so of lecture just on how these LCD screen works with the two different chips and everything else, and kind of going through how everything works with these nibbles and this bit masking and all sorts of stuff. And I encourage you to make sure you understand this. We watch those videos. I mean, these are very important concepts, and I'm trying to demonstrate the fact that, look, even me, who I've done this stuff for a long time, when I see a new data sheet, it takes me a long time to decipher through everything. So don't be shocked that when handed a data sheet, and you have to read it 6 or 7 times before you truly understand it. And so what I'm going to do here is we're actually going to start writing some of the code, but I'm just going to go ahead and copy these, because the first thing I want to do is at the top of my code here is declare all of my variables here. So I've declared all my global variables now, and I could initialize them to something. It's really not necessary to. The reason it's not necessary to is I know I'm going to initialize the values before I ever use them in the program. So if I know I'm going to initialize them already before I ever use them, I should be okay. Now, this initialization one here, let's just go ahead and do a quick description of what this is going to be here, this function here. So the initialization is basically sets global variables and initializes masks for, let's just say, sets global variable initialize masks for display on, cursor on, blink off, entry is from the right, I'm sorry, not from the right, from the left, and increments. So basically meaning that I am going to start from the left side and increment, and just do basically what's going to be considered automatic shifting. Cursor will move, in other words, cursor and increments cursor to the left. Because what you can do is you can actually have this in a couple different modes. Incrementing cursor from the left is basically, or not to the left, to the right, is how you would normally type. It's like how I'm typing now, in the sense that I'm starting on the left-hand side. I start on the left-hand side and I type something, and then the character moves, over, the cursor moves one. That's kind of the entry left and increments. But there are ways that you can have it where the cursor actually always stays in this position, and what happens is it scrolls across. Just like, if you have, banners outside of businesses where they have something scrolling across the banner. You can actually have it set up to do that as well. All right. So that's all we're going to do here for this function. So there's not really a lot going on in this function here. So first off, if we see that LCD address here, I'm just going to say, well, I know I need to set this then to what was given to me. Okay, so I use that. And I know it gets a little confusing here, underline LCD address versus LCD underscore address. This is what the person is entering as the user, not what we are storing as a global variable. And then LCD, and I have my caps lock on or something. LCD columns is just going to be LCD calls. And then LCD rows is just going to be LCD rows. And then LCD character size is just going to be character size. All right, so we've initialized a bunch of those variables already. We've initialized these bottom 4 right here. So let's initialize some other here. We'll go ahead and initialize the display, and we want the display on, cursor on, and blink off. So what we're going to do is we're going to initialize LCD display, and I'm going to do the LCD command display because I need to, this global variable contains both the command and the bit masks. And so what do I want to do? I want to OR that with, well, I want the display on. So I'm going to do LCD display display on as the macro. And then I'm going to do another LCD display, and I want the cursor on. But the I want to make sure here that no, actually, I don't need to do that. I was going to say I want to make sure the blink is off, but this is just initializing it here, so we don't have to worry about the blink off because this is the first time we've done it. So just by doing it this way, the blink's automatically off since I haven't turned it on. Okay, so then let's also initialize the LCD display shift. And let's go back to the data sheet to see how we want to initialize that. Because we said we wanted to entry from the left. And so let's, I'm sorry, just kind of spaced out there for a second. And so we want to, let's see here, go to the, cursor, that's not what I'm wanting. I'm in the wrong variable here. Let me pause this a second here. We're not wanting to initialize the display shift. I'm sorry. What we're wanting to do is the entry mode. I got this wrong here. So again, you have to be careful, making sure you read everything carefully. The display shift is actually allows you to move the cursor around on the screen. So like that's how we're going to be able to set the cursor to a particular position on the screen. So we can move it left or right, you know, so on and so on as far as moving the cursor. So that's what the display shift is going to be for. The entry mode is where we tell it the cursor move direction and specifies the shift. Okay, so we're going to want to do increment, so that's a 1, and then we're going to have the cursor accompany the display shift as well. That's what we're going to want. Basically, S being 1 saying accompanying the display shift is that basically once I hit the character, you know, and I do the next one, it will print the next character in the sense that the cursor moves with the display. So we want entry mode. Well, I need the command entry mode set LCD entry, and I want it to be incrementing, and LCD entry, and I want the shift. I want it to be shifting with the as data is being sent in. So I don't actually need to do the display shift one, And the function set one I'm not going to initialize, because the function set one, if we go back here, it does data lines, numbers of lines, n, and format, but DL also stands for 8 bits or 4 bits. And so there's a whole procedure we have to do in order to get it into 4-bit mode. So we'll save setting the function set until we actually get to that. So at this point I've initialized it. So the only two that I haven't initialized are this display shift, which, as I said, is only really used for moving the cursor around, not for actually, getting it set up. And then the function set, which the function set we'll use in the actual start command for starting up the LCD, because there's a whole procedure we're going to have to follow on the data sheet. All right, so before we even get to that, we're going to write a couple of other easy functions here. We're going to do the write byte function here first. And this write byte function is going to let us, again, write bytes to the device. And so let's first remember here that for the write byte, we have to, well, I'll let you write the function headers. We have to remember, we talked about this several times, we have to split this into 2 nibbles. And so I'm going to first say, well, in this function I'm going to need 2 more variables. I'm going to need a high bit nibble, so this is like the high 4 bits. And this would be the low nib. So this, in other words, this is D7, D6, D5, and D4 is the high nib. And then this is D4, D3, D2, and D1 for the low nib. Okay, so I have to get the high nib and the low nibs. But actually getting the high nib, we even wrote this out by hand, I believe, in some of the previous videos. It's actually pretty straightforward. This is going to be equal to, well, the byte of data that's been sent, and we're going to AND it with 0xF0. Because what we're ANDing it with is, so we have byte D7 ... down to D, actually this is wrong, this should be not D4, D3, D2, D1, D0, all the way down to D0, ANDed with 111100. And so that means we're going to just strip out those first. You might say, well, why am I doing 8-bit if I'm writing a nibble? Remember, we're still going to ultimately write a byte. It's just the high 4 bits of this are our data, and then the low 4 bits are the mode, like backlight on and whether I'm reading and writing and things of that nature. And so what we're going to do here is I'm going to then get my low nib, and I want it stored in the highest 4 bits. So what I'm going to do first is, well, there's a couple ways you could do this. I'm going to think about it as I'm going to shift the byte 4 spots to the right to start with, and then AND it with F0, 0xF0 again. So what is this doing? Well, the first thing is I'm basically shifting it, and I'm shifting it such that I have now D3, D2, D1, D0, and then I'll put X, 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 because technically those should be zeros when I do the bit shifting, but I don't know necessarily what they are. So I'm going to AND that then with 1, 1, 1, 1, 0, 0, 0. Now there is another way you could have written this. You could have also done this as low nib is equal to byte ANDed with 0x, 0f, which is I think what we did originally in the videos, and then bit shift it 4 spots to the left. Both those commands will do the exact same thing. They're just doing it slightly differently. Okay, so then I've got my high nib and my low nib. Now I just need to do write those nibbles. So I'm going to do a write nibble. I'm going to do the high nib, and I'm going to OR it with the mode, because remember the mode is those enable buttons and the register select and the read write and also the backlight. And then I'm going to LCD write nibble low byte or low nib ORed with the mode. Because again, if we look in the data sheet, if we think it's down further here, I know I'm scrolling through this fast right here. See, when you're writing here, you know, it has here display off, display clear here. You know, the display clear is this command right here. And so when you're saying write a nibble, you're doing 0, 0, 0, 0. That's the high nib. And then the low nib is 0, 0, 0, 1. And that does a display clear. So that's why when we're writing a byte of data, we're going to write 2 nibbles. All right, so I've got my code here now for writing the byte. So I now need some code for writing a nibble. And this is actually pretty straightforward. So we're going to now do my I2C, and I'm going to start up the I2C bus, and this is where I'm now using the global variable of the LCD address, and then I'll put it in write mode. And I cannot type again today. Write transfer mode. And I will do infinite timeout for now. And then I'm going to go back again to the data sheet here and find, it was in the bottom here, in these data sheets here. Clock characteristic. Here we go. The read and write times here. So the enable pulse width. We have to have this up for 450 nanoseconds. So I need to have that up to a 1. That enable up to a 1. So I'm going to first write. Seems a little weird, but I'm going to write here master write byte. And I'm going to write my nibble, but I'm going to OR it with the LCD enable. And why am I ORing it with the enable? Because that puts that 1 in. That turns the enable high. Because the nibble has, right now, what does the nibble contain? The nibble contains essentially, if we're talking about, I'll just do it like this: data 6, data 7, data 6, data 5, data 4, backlight, enable, read write, register select. So when we did the mode, for instance, we had set this to 1 to turn the backlight on. For this command, we're typically going to have 0 zeros for those, but that's when we said the mode, we're sending this information. We're essentially going to be sending like 1, and this will probably be 0, because we want the enable to be 0 initially. So this is what we'll have for a mode when we go to write a nibble. It's going to be 1 0 0 0 typically, because we want the backlight on. The enable should be at the 0 line, and then we need it to be in write mode, which is 0, and then we need the register select to be 0 as well. And then it says, okay, well now we need to pulse the enable line high. Remember those timing diagrams we looked at? And it needs to be high for 450 nanoseconds. So this LCD enable, if I hover over it, is 0x04. So what does that do? That puts, sorry, wrong spot. That puts a 1 right there. So that's going to turn the enable line high. And so that's what we need to do. And then I forgot my semicolon. And then we need to delay. Now I need to delay for at least 450 nanoseconds. Well, we have to be careful. If I do CY delay, this is in milliseconds, and it's an integer. You can't put in 0.001 for that. That's going to treat that as 0. So it's not going to delay at all. So I can't do 0 milliseconds. I can't do decimal numbers. Well, if we go to the CY delay here, there's several different things. You know, if you want to get very precise, you can delay for a certain number of clock cycles. But of course, you need to know what the clock speed is and everything. Or there is a microsecond one. Okay, so 450 nanoseconds is not microseconds again, because if I do this one, I still need to put in an integer. But one microsecond is close to 450 nanoseconds. Yeah, it's twice as much as 450 nanoseconds, but it's just that it has to be at least 450 nanoseconds. Notice that the data sheet says there is no maximum pulse width here. In fact, I could have it up there for as long as I want, which would be stupid, but I just have a minimum that I have to be. Minimum of 450 nanoseconds. Now, we want to hit as close to the minimum as you want. There's no sense in delaying more than we need to, so we'll delay for 1 microsecond. And then we'll do an I2C master, write byte, Nibble. But now we're going to AND this, and we're going to do a bitwise LCD enable with 0 time. Because what we're wanting to do here, let's write out what we have here in the comments. We have D7, D6, D5, D4, 1, 1, 0, 0 is essentially what we have. And we're going to AND this. Now, since that's a bitwise one, this would be 1, 1, 1, 1, 1, 1, 1, 0, 1, 1. So we can see that as a result, we'll get D7, D6, D5, D4, because ones with these are just going to repeat whatever these are. And then I have a 1 ANDed with another 1 here. So that's 1. So the backlight stays on. 1 ANDed with a 0, which makes this back to 0. So now we've pulled that enable line back to 0. And then we'll have 0, 0 for the register select and the read write. And again, I'm going to scroll back up to a timing diagram here somewhere to show again, why do we do this? And this is because this is what the data sheet tells us to do. I just had one and I scrolled past it here. Actually, this isn't the one I want here. Right here. This is the example of doing how we would do 4-bit timing. So this is the data that we're trying to send. Okay. We pulse this enable on for at least 450 nanoseconds. We're doing it for 1 microsecond, but then we have to pulse it down low before we send the next set of instructions. There's a time here that we have to have this delayed for. Now, what's interesting is this diagram isn't actually reflecting very well the actual amount of time we have to delay, because if we go to our table, actually I went back the wrong way. our table, our delays here are 37 microseconds. So we want to make sure to delay for enough time so whatever commands were being executed have time to execute. So we'll do a cy delay microseconds. If I could actually, I keep forgetting to put the semicolon here. Cy delay another microseconds, and we'll do, I'll do 50. That's what I had in the code when I was testing this. Okay, so now we've written this nibble using that enable pulsing. So it's a tricky way to do this, but this, quite frankly, is some of the most complicated stuff we're going to have to do in this API here, is getting that nibble split apart and actually writing a nibble as opposed to writing just a single byte here. But notice we still are writing bytes. It's just we're having, again, this is our nibble that we're writing, and then this is the backlight, enable, read, write, and register select. Okay, so the last thing we should, of course, do here is we need to shut down the I2C line. Oh gosh, I can't spell again, or type. I want to send a stop, and I'm going to, again, delay just for infinite time, because I want to stop transmission, even though the very next thing is I'm doing another write byte here, low nibble. You honestly don't know what else is going on. Maybe there's an interrupt that's generated and we actually have to pause before we write that lower nibble, or just the fact that, we want to make sure that once we're done writing that low nib, that it's actually the I2C bus is free and open again for everyone. So I'm going to end the video here. We've gotten two very critical functions written here. As I said, in some ways, this is the most complicated thing we're going to do. The next one, you might say, when we actually write some of the stuff for the startup, seems like it's complicated, but it's really not. So let's go ahead and pause, and we'll talk that in the next video.